Okay, so for congruent triangles, there are 4 different cases. The first one is the most simple, which is just all the sides are the same. So if all the sides are the same, they must be congruent, meaning they're all the same. So if we see that this one here lines up, so AB lines up is the same as DC.
DC, yeah.
Good. And then AD and BC are the same. And then BD is the same. So when you label these, it's important to label them correctly. So in other words, if you say ABD, so say you say triangle ABD.
Yep.
And so when you're proving triangles, you always say the same thing, which is in triangle ABD. Now, what they'll often do is they will tell you prove the triangles, and then they'll tell you which ones to prove, and then it makes it easier because then you know the order of the letters that you have to put them in. But if you don't, and you need to just prove congruency, but you don't know which triangles, you have to line them up. So if you see that AB, ABD, so it goes blue and then yellow, then we have to say CDB, right? CDB, because it's got to go blue, yellow. So often a good tip is to actually get some highlighters, because then it helps you to see. So ABD and triangle CDB. Okay, so if I go AB is kind of blue and CD is blue and BD is pink. BD is yellow. AD is pink. So AD is pink. And we see CB is pink. CB is pink. So all the letters line up and they correspond, and that's important. And then BD is this yellow, and then BD is yellow because that's obviously common. So that's just important to get the naming right, because then when you want to prove like with similarity, or if you want to prove proportions or something, then it makes it easier to have them in order. So we start with AB equals, so the blue one equals CD. And the reason is?
Would it be given?
Excellent, yeah.
Yeah.
Given. And then AD equals BC.
It's also given.
Cool. I'm going to say CCB. It's the same thing. Given. Good. And then what's the last one? BD. It's weird to say, but we say BD equals BD. And what do we say there? What's the reason?
Common.
That's it. Okay. Okay, so that's the most simple we'll probably get. And then you'll say, therefore, triangle, and you'll just write down exactly what they said, but then instead of saying and, you'll say it's congruent to triangle CDB, and the reason is side, side, side.
Very cool.
Okay, so that's the first case.
Yeah.
Okay, now the second case is side, 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 angle, side. So you have to have two sides that are hugging an angle. So the angle has to be between the two sides, like it's written. So the angles are easy because those are in pink there. Those are both the same. And then the sides, we have a common side over there. So, and then this one is given to us. Okay, and again, we have to make sure that we write the triangle properly. So we say in, we say in
triangle.
Yeah. Okay. Yeah, carry on. You tell
triangle ACD.
Okay.
Or ADC, doesn't ADC.
You're going to go ADC. Okay, good.
Is in triangle ADC, and ABC.
Excellent. Good. Good, because it's going orange and then,
yeah.
Good.
And then underneath you say triangle. Wait, triangle ADC. No, wait. Do you put triangle ADC equals ABC, or what you did for like the last part?
That's at the very end. So now we're just doing
Okay.
the three things that we have to prove.
So AB equals AD. That's given.
AB equals AD. Good. The two orange ones. Nice. Given. Okay.
AC equals AC because it's common.
Nice.
And
so sometimes they'll help you and they'll give you like 1 and 2, right? They'll say, so you could say A1 equals A2. If they don't, we have to name the triangle, then name the angle.
Okay. So then A1 equals, okay.
So
okay, so BAC, equal.
We put the hat on the middle, good, equals.
Equals DAC and the little cap on the A.
Good.
And then that'll be given.
Right. Therefore.
Right, cool.
So then we just repeat what they say, right?
Yep.
And we've got two sides and an angle, and the sides are hugging the angle. So that's fine. Angle between two sides. So that's that one done. Okay, now let's look at this third case. So when you see right angles and similar triangles, you're almost certainly going to be looking at that RHS. So as soon as you see a right angle, you know, okay, this is probably RHS. Okay, so what are we going to say? In
triangle ABC.
Okay, so you're going ABC, right? Okay.
Yeah. In triangle ABC and triangle ADC.
Good. It's the right order.
And then AB equals equals AD, and it's given.
Good.
AC equals AC equals AC.
Yep.
It's common.
Nice.
And then C1 equals C2, and it's given.
Cool. So we know how to label them, so that's a good idea. Let's just do C1 and C2. So we get both options. Okay. And then we have to say equals 90.
Oh yeah, okay, cool.
Therefore, triangle ABC is congruent to triangle ADC, and we just put RHS.
Very cool.
Okay, and finally, so we've done two sides and an angle, we've done RHS, and now we're looking at angle, side. So we get the two angles and the side. So this is often the most tricky because they'll give you parallel lines or something like that. So sometimes it's easier to kind of do the work on the diagram first.
Yeah.
So, that corresponds to that. So wherever you put B in the one, you have to put D on the other. So because B and D correspond to each other. And of course, for the same reason, because of these alternate angles and parallel sides, we know that these two are equal. So that was our, do you remember the Z? Alternate angles.
Yeah, it's out of blank. Yeah, out of blank.
Okay, so there's the Z there for the pink. And of course, there's for the green there. Okay, so what are we going to name the triangles?
BAC
BAC, good.
and DEC.
Excellent. Very nice. So yeah, because B is pink and D is pink. And A is green. And E is green. And of course, C is that common one there. Okay,
Okay, and then A equals E. And are we alternate angles?
A equals E. Alternate angle.
Your parallel lines.
Good, we name the parallel lines.
Just AB is parallel to DE.
Excellent. Next one.
B equals D, and it's the same one.
Oops. Last one.
And then C equals C, and it's just it's common.
Okay, so that would be three angles, which would give us similarity, which is not enough for congruency. So in other words, if we had this, this could just be similarity, not congruency, right? Because if you had a triangle like that and a big triangle, that that could be equal to that, and this could be equal to this, but they're not congruent. They just like mini-me in Austin Powers. They're exactly the same proportions, but different sizes. Okay, so what are we going to say? What's the third thing we actually need to say? This is the clue here: angle, side. Given this, it's difficult.
BC equals DC.
Yeah. And that would be
given.
Good. Right, and then you can say therefore triangle BAC is congruent to triangle DEC. Pass. Okay, so those are the four cases for congruency. We had side, side, side. We had side, angle, side. We had RHS, and we had angle, angle, side. So those are what you're looking for when you are trying to figure out these questions.
Yeah.
Okay.